Fourth grade into math, recognize lines of symmetry. I can identify a line of symmetry on a two-dimensional figure. Okay, so we just talked about that. What is a two-dimensional figure? It's flat shape, right? Okay, 3D means it's popped out and has multiple sides, right? Okay, and then we talked about line of symmetry. Basically, if you would hold a mirror on a paper, you should be able to see what's in the mirror on the other side of the mirror, right? Okay, the side that doesn't have the reflective side. Okay, also, if you were to fold that shape in half, should what is on the one half line up with the other half if you folded it in half? Yes. Okay. So sparking your learning. Meta's class is studying the climate and wildlife of Argentina. They are following the activities posted in an online journal by a team of scientists working in Patagonia. Meta's class views photographs of snowflakes shared by scientists. Analyze the snowflake. Can you find a way to fold the snowflake along a line so that it has two parts that match exactly? How many different ways can you find? Draw the possible fold lines on the snowflake. Okay, so what you're going to do is I'm going to give you a little time with your mirror to put it on your paper and decide where you think the fold line could be, right? Or where the line of symmetry could be. We're not drawing anything yet. You're just trying to figure out where it could possibly be. Okay, so we're putting our mirrors down and we're going to draw our lines of symmetry. Okay, I clearly can't put a ruler up on here, but you can put a ruler on your paper to draw it, right? Where was one? Was it straight down the middle? Okay, so I'm going to line my ruler. I would line my ruler up with the points of the snowflake, and then I would draw a line straight through the middle. And yours should be straight because you're using a ruler. So if we would rotate our paper, could we go from this tip of the snowflake to this tip of the snowflake? Would that also create a line of symmetry? Yes. What if I went from this tip of the snowflake to this tip of the snowflake? Would that also work? Yes. Okay, so basically, if we would cut out this snowflake and we would fold it on these lines, would both sides match up? Yes. So it created a line of symmetry there. Is there anywhere else that I could create a line of symmetry with this snowflake? Where else? At the points or the triangles? Okay, so I could also do a line of symmetry here as well, right? Like I said, hopefully your lines are more straight than mine because you're using a ruler. All right, can I also go to the other point right here? Okay, and then can I go to the other point? Yes. So technically, how many lines of symmetry does this snowflake have? Well, how many? 6, right? Because I had 3 using the rounded tips of the snowflake, and I had 3 using the pointed tips of the snowflake. So this particular snowflake has how many lines of symmetry? 6. Okay, so 6 lines of symmetry. Okay, vocabulary. A line of symmetry is an imaginary line on a figure about which the figure can be folded so that its two parts match exactly. If a figure has a line of symmetry, it is said to have line symmetry. So, Meta's class is making a display about the seasons in the southern hemisphere. At the top of the display, they want to put the letters WINTER. How can you tell if the letters have line of symmetry? So, I want you to use your mirror and use them on those letters and decide if these letters have line of symmetry. Okay, so letter A says, look at the letters. Are there any letters that you can fold so that each side of the letter is exactly the same? Choose those letters. So what do you think? W? Yeah. I? Yeah. Okay. N? No, it's kind of a tricky one because it does kind of look like that. But if you would go to fold it, they wouldn't line up, right? Okay, T? Yeah. E? Yeah. R? No. Are there any letters you can fold in more than one way and have the size of the letters folded to match exactly? Any of those you can. Yeah. Which one has more than one line of symmetry? I. Letter I, because you could take it and fold it this vertically, and you can take it and fold it horizontally. Okay? Draw a line to show where each of the possible folds are that divide the letters into matching halves. So, W, would we have a vertical line of symmetry or a horizontal line of symmetry? Vertical, so up and down, right? Straight down the middle. Okay? And we said would not. T, would it be vertical or horizontal? Vertical. E, vertical or horizontal? Horizontal. Okay, so letter D, which letters have lines of symmetry? We circled them, right? So W, I, T, and E, correct? Yes, no? Okay, which do not have lines of symmetry? N and R. Okay, so Sonia draws a picture of a lab that is designed for the cold weather in Argentina. Look at Sonia's drawing below. Does her drawing of the lab have lines of symmetry? Explain why or why not. Yes or no?
Yes.
No, because if I would go horizontally, so if I go left to right, would the top match the bottom? No. If I went vertically, so top to bottom, and folded it in half, would it have lines of symmetry? No, it would not. It would if you got rid of what? The chimney. And with that chimney on there, I don't have a chimney on this side, right? Okay, so is her picture a line of symmetry? No. Okay, so now they want us to redraw it so it would have a line of symmetry. So what did we say we would have to get rid of to have that? Get rid of the chimney. So I need to still draw exactly like this. So I am going to draw my line of symmetry down the middle so I can kind of base my stuff off of that. Okay, then I have 1, 2, 3, 4, 5. So if I start my dot right here and go 1, 2, 3, 4, 5, here's my other one for the tip of my triangle. 1, 2, 3, 4. Oh, I went 1, 2, 4. Sorry, guys. On this one. So we should be right here. And 1, 2, 3, 4 plus the one up there. Okay, so we can connect those points for the tip of our house or the triangular part. Okay, then can I go ahead and draw the square base of the house? Yeah. Yep, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I can put a little dot there, come down, put a little dot over here, connect them. And then my door goes up 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and then my rectangle skips the line and then comes out one space past the door. So did I use my line of symmetry to help me draw my house?
Yes.
Yes. Okay. Did that give me a better idea of position and how many spaces to go? Yes. Okay. So now if I folded that house in half, should it match up? Yes. Number 1, check for understanding. Circle the letters that have a correctly drawn line of symmetry. A?
Yes.
Yep. If I would fold that in half on that line, then I would get it to match up. B?
Yes.
No, and what tells me automatically that B would not work? Because on one side of B it has a straight line, on the other it has curves. So would that match up? No. What about letter C? Yes. What about letter D? No. Once again, it's kind of like B. I have a straight line on one side, and on the other side I have a curve. So if I tried to match it up, it would not work. On your own, number 2, attention precision. The scientists in Argentina share illustrations from their work. Tell whether the drawings have 0 lines, 1 line, or more than 1 line of symmetry. Draw all lines of symmetry. So we kind of looked at some of those other letters and we looked first like horizontally or vertically, right? Okay, but like the snowflake on the front page, we did both horizontally and vertically, but what else do we do? Diagonally as well. So you need to check multiple ways. Okay, so let's look horizontally first. Can we, left or right, put a line of symmetry for that first snowflake? Yes. Okay, so right here, we can put a line of symmetry. Okay, so horizontally, we can draw our line, right? Okay, so we're going to do these on our own and then come back and check together later.